Imagine one day that you get a notification from your bank saying that you've just received $1. You weren't expecting any payments, and $1 is a weird amount to receive, so you log into your bank to have a look at the transaction. You have a look, you've received the dollar. The only thing that's odd is you don't know who it's from. Go by one day, you log into your bank account, and your entire balance is missing, 0. What the hell happened? Well, likely you were a victim of a cross-site scripting attack. But what exactly is cross-site scripting, and more importantly, how can we protect our users from such attacks? Cross-site scripting is a security vulnerability which allows an attacker to inject malicious JavaScript into the web pages viewed by other users. It is essentially code execution in the victim's browser. To the user, everything looks normal, but in the background of the website, the script is running to steal session cookies, credentials, keystrokes, and other personal information. This occurs when a website accepts input from an attacker, which is then included in part of the website without being validated or encoded. Because the script appears to come from the server, the browser has no way to know that the script shouldn't be trusted. Let's jump in and take a look at examples for the two main types of cross-site scripting vulnerabilities. Take a look at this login page. If I enter a username and wrong password, notice how the application reflects that username back into the page. Seems helpful, right? However, because the input isn't being sanitized or escaped, the browser can't tell the difference between a name and code. If I add a script tag, the browser executes it immediately. This is known as reflected cross-site scripting. The value is not living in a database, but it's bouncing off the server and executing in my session, opening the door for an attacker to steal session cookies or redirect the user. In this next example, an attacker is sending money to a victim. They submit a standard transfer, and when the user refreshes, they see the record loaded from the database. So the attacker tries again, but this time instead of a real description, they send a JavaScript payload and submit. When the user refreshes to see the new transfer, the browser doesn't render the text, it executes the script. This is known as a stored cross-site scripting. We can see this by viewing the page's source code to confirm the browser is seeing a script tag instead of encoded text. Stored cross-site scripting differs from reflected because the payload is permanently stored by the server and executed every time a victim views an affected web page. Reflected, on the other hand, requires the payload to be in the original request to the server. Now, while this all sounds gloomy, thankfully cross-site scripting can be fixed quite easily in modern times. The main defense against cross-site scripting is to always encode user-controlled variables when they're outputted to a web page. In our Go example, we simply need to use the HTML template library instead of text template. The library will automatically encode user-controlled data wherever it's being inserted into the web page. This forces the browser to interpret our injected script tag as text rather than an actual script tag. If you're using a different programming language or templating language, just make sure to check that variables are escaped by default. If you're using a front-end framework like React, Vue, or Angular, these will automatically perform the escaping for you. However, always check your library's documentation to make sure you're not bypassing the built-in protections. For example, React has the dangerously set in a HTML property. If you see unsafe functions like this being used, be sure to investigate further. Despite all these libraries having built-in protection, cross-site scripting is one of the most common vulnerabilities exploited in the wild, with more than 30,000 CVEs reported in the OWASP Top 10 of 2025. But thankfully, educated developers like yourself won't become part of these stats.